Hey guys, we're back. Let's go ahead and start talking about composition of functions, but the second part, we're doing a little bit more of it. So here's how to find a composed function that doesn't have a specific value. Okay, so you notice here that we're looking for f of g of x, not a specific value. So here's what you're going to do. Instead of the specific value where we did the inside first, then the outside, if we did the inside here, this would not help us because it wouldn't be simplified. So what you're going to do of a composed function is we're going to do the outside function to give us the skeleton of the function. And then we're going to input the inside function. Okay, so here's what we're going to do. We know that the outside function here is f. So here's my outside function. So instead of x, you're going to use parentheses. Okay, so instead of x, we're going to use a parentheses on this outside function. So parentheses x squared minus 1. That's our skeleton function. And then the inside function is g of x here, and that's what's going to fill every parentheses. So this is our f of g of x. Once we have that, we can simplify. We know the root of x squared is just x minus the 1. So this is our f of g of x. In just a little bit, we'll talk about the domain, but here we go, number 2. Again, we're going to find f of g of x. So here, because this is a non-specific value of x, we're going to do the outside function as the skeleton. So f of x is 2x minus x squared. And then our inside function is g of x. So this is going to take the space of every parentheses. And then here, now we're going to simplify. We can distribute that 2. We get 2x plus 2 minus, and then we know x plus 1 squared is like foiling x plus 1 times x plus 1. That gives us x squared plus 2x plus 1. Don't forget to distribute this negative through. So we end up with 2x plus 2 minus x squared minus 2x minus 1. Simplify like terms. We get negative x squared plus 1 is our f of g of x. So that's how we find a composed function, but how do we find the domain of a composed function? So there's two parts. So when you're finding the domain of a composed function, f of g of x, you have two restrictions to consider, okay? First, you're going to look at whatever's your input. You're going to see what are any restrictions, if any, on that domain. Okay, and then secondly, you're also going to consider the result of your output g of x function and see that domain as well. Any restrictions that apply to both the input and the output are the overall restrictions for your whole function. Okay, so let's talk about what that really looks like. Oh, keep in mind, remember that red flags for domain, okay, or restrictions. Okay, what are red flags or restrictions for the domain? Anytime we have a root, we know there's got to be a restriction because roots can only be 0 or positive. They can't be negative. And then anytime we have a variable in the denominator, we know that the denominator cannot equal to 0. So there's two. Those are the two pretty much that we're looking for. So start using problem number 1. Let's find the domain. So first of all, f of g of x, we found already was x minus 1. And if I'm looking here, there's no restrictions because I don't have a root and I don't have a denominator, so there's no restrictions. We also need to look at the input. So what did we use as an input here? We used g of x. Well, g of x here was the root of x. So if g of x is the root of x as your input, this is a problem. We do have a restriction here because we have a root. So that means I know that x has to be equal to 0 or x has to be greater than 0. So how do we say that? Well, then our overall domain is that x has to be 0 or greater in interval notation. All right, let's look at number 3. It says if f of x is the root of x minus 1 and g of x is x squared minus 8, find f of g, then state the domain. So let's go ahead and find f of g. So remember, this is a non-specific composition. So we're going to take the outside function first as the skeleton. So the root of x minus 1, we replace the x with the parentheses. And then inside the function is going to be x squared minus 8. That takes the place of all the parentheses. And now we're going to simplify. So we know that this becomes x squared minus 8 minus 1 is the root of x squared minus 9. This does not have a perfect root, so this is all that we can do. So this is our f of g of x, okay? So here's our composition. So let's find the domain. So two things, where do we see a red flag? So first of all, what was our input? So this was our input here, g of x. This has no restrictions because it doesn't have a root and it does not have a denominator. So this has no restrictions on the domain. Now let's look at the composition. We do see a square root here. So we know that the restrictions is that, hey, this square root has to be equal to 0 or greater than 0. So we say, hey, x squared minus 9 has to be greater than or equal to 0. So let's go ahead and solve this. Add 9 to both sides, and we get x has got to be equal to plus or minus 3. So now we want to be careful with this because with squares that can change the direction of your greater than sign. So let's put this on a number line. We'll put -3 here and positive 3. We know that it can equal both of them, but we want to see which way is it going. So what values would x squared minus 9 actually be greater than 0? That tells me I know the number has to be greater than 3, like if it was 4. 4 squared would be 16 minus 9 is greater than 0, so it's going to be above 3. And then also below 3 here. So this tells me that our domain is from -infinity to -3 and from 3 to positive infinity. That's our domain. So how would we find g of f of x here? And then find the domain. So again, you're going to use your outside function first, which is g, as your skeleton. So x squared minus 8. And your inside function is going to be your f of x. So that's going to be your root of x minus 1. Once we have that, we're going to simplify. I know that a squared cancels that root. So this is just x minus 1 minus 8, which becomes x minus 9. So here's our g of f of x. Okay, so now let's find the domain. Remember the domain, we're going to look at two things. We're going to look at our inside function. So what was f of x? F of x was the root of x minus 1. Again, this is a red flag. We've got a root here, which tells me we have to look at its domain closely. We know that with a root, that x minus 1 can either be equal to or greater than 0. So if I solve this, I know x has to be greater than or equal to 1. And then our composition, we also need to look. There are no red flags. There's no restrictions. So this is our only restriction. This tells me that our domain has to be either 1 or greater. Okay, turn the page. And lastly, how do we decompose functions? So again, remember, we're looking for inside function and outside function, okay? So when we're looking at the inside function and the outside function, we want to see, okay, what's kind of that skeleton and what's on the inside. So here, remember, I'm looking at f of g of x. Remember, g of x is the inside function, and f of x is the outside function. So looking at h of x, I know the inside of the root is the inside function, which means that that g of x, meaning the inside function, is x cubed plus 1. So if I magically turned this into just an x, what would the outside function look like? Well, the outside function is just this root. So we know it's got to be the root of whatever x is. So same thing here. For number 5, we're going to look for the inside function and the outside function. So inside the denominator, I see x squared plus 1. So that tells me that the inside function, g of x, has to be x squared plus 1. And that the outside function is going to be 1 over whatever this is, which we'll call x. So if I were to put g of x into x, this would give me my composed function. Okay, just a quick little note, never, for decomposition of functions, we never use the identity function for this because it doesn't decompose, it stays the same. All right, thank you. We'll see you back in class.